Good morning, everybody. So today we're going to talk about the composite functions, and I have an example on the board already. And the example is f of x equals to 2x squared plus 3, and g of x equals to 4x plus 1. So remember, when we're doing the composite functions, this is a simple operation kind. It's just adding, subtracting, multiplying, or dividing the two functions together. So let's start with adding the two functions. F of x is 2x squared plus 3. G of x is 4x plus 1. So all we would have to do to add it is to literally write 2x squared plus 3 plus 4x plus 1. So, what are the like terms in this? Well, the two like terms that I can see are this positive 3 and this positive 1. So my final answer should come out to be 2x squared plus 4x plus 4. So, things to remember is that when you are combining functions together, you are combining like terms. And remember that like terms have the same power and variable. And when we're talking about combining, we're specifically talking about adding or subtracting. When we talk about multiplication or division, most of the times you can divide or multiply anything without necessarily having to have the same base with the same exponent. So let's look at f minus g. F minus g is written a little bit differently. 2x squared plus 3 and minus. This time I'm going to have to put a parenthesis around the 4x plus 1 because we're going to have to distribute out that parentheses. So I take that negative and distribute to both the 4x and the 1, and what I end up with is 2x squared plus 3 minus 4x minus 1. So it changes my answer just a little bit because now I have a plus 3 and a minus 1 instead of before where I had a plus 3 and a plus 1. So my final answer should be 2x squared minus 4x plus 2. And notice that the 4x is now negative instead of positive. Multiplication, you can do this many ways. You could FOIL, if you remember FOIL. I don't like FOIL. I would prefer to use the area model because in my mind it makes a little more sense. Because if I were to label these segments as 2x squared plus 3 and 4x plus 1, then I can find the area of each little rectangle with those segment measures and add them together. So 4x times 2x squared is 8x cubed. 4x times 3 is 12x. 2x squared times 1 is 2x squared. And 1 times 3 is 3. So my answer for multiplying would come out to be 8x cubed plus 2x squared plus 12x plus 3. And notice that there is nothing here to combine, so I am not going to combine it. Now the very last one is f over g, division. That's 2x cubed. Sorry. That would be 2x cubed plus 3 over 4x plus 1. Now, about this, that's a square. 2x squared, sorry. About this, most of the times you really can't do much division. In fact, if there's nothing you can factor out, then there's really no reason to simplify this any further. You can kind of consider this as like an improper fraction. And when you have an answer, for example, 11 over 3, no one ever really expects you to write this as 3 and, well, I don't know, 9, 2/3. No one expects you to write it as 3 and 2/3 because you're going to divide 11 by 3 to get 9. It's 2, so that's 3 and 2/3. No one ever expects you to write something like that because improper fractions are actually a lot easier to work with than mixed numbers. It's the same with this. This I could divide out, but there's no point because if I were to try to divide it out, I am going to end up with the variable, the polynomial version of an improper fraction. So this really is the simplest form, unless there is something that you can factor out of 2x squared plus 3 that divides into 4x plus 1. But there isn't, so we're not going to. And that's it for adding and subtracting, multiplying, and dividing two functions. Tomorrow we're going to be talking about the composite function, which is going to be just a little bit more difficult, but not so bad. Good luck.